Right. So we're going to talk today about two kind of interesting character sets, really, for want of a better word. One is called ASCII, ASCII, and the other one is called Unicode. And you have to put a registered trademark on the Unicode because it is actually a registered trademark. So what are these two things? Well, it all comes back to bits. Okay, so almost everything can be represented by binary code. So what words, images, sounds can all be turned into bits and processed by the computer. Okay, so the first thing we're going to look at is the words, the characters. Okay, binary can be used to represent characters. Okay, so we're used to a standard alphanumeric Roman alphabet in the Western world. If you go to the east, you've got glyphs and characters that are represented by shapes and pictographic. You've got Cyrillic. You've got then you've got your kind of Middle Eastern Aryan type of scripts, you know, the ones from the likes of India and the Arabian Peninsula. So you've got lots of different types, but the ones that we're going to deal with and why this causes a problem is, you know, the standard alphabet. Okay, so obviously, apart from all the letters A to Z, you've also got the uppercase, lowercase, all the digits and all the symbols like a question mark, a euro sign, and all that type of thing. So obviously, computers are unable to process these characters directly. They can only do a true binary code. So they need a way of converting the characters to binary and the binaries back to characters so they can be, and they use what's called character sets. Okay, so they use a character set. Okay, and a character set is a collection of characters that can be converted into binary and vice versa. It's not a font. That's not what we're talking about here. So it's not a font. Okay, font would actually be part of it. You know what I mean? That's just the way the HTML does it. But no, you've also got the special characters like the enter space. You know, it's all those things that can be accessible on a standard keyboard. Okay, so when you press on your keyboard, you're basically sending a little signal in binary. Okay, the computer tells you which button you've pressed. The computer then uses the character set to translate the binary pressing of that button to a particular character which appears in the pixels on your screen. It's as simple as that, or as complicated as that, depending. Okay, there's different character sets can have different amounts of characters. Okay, the most commonly used one is called ASCII. Okay, it stands for, I think, the American Society for Computer, something like that. I honestly can't remember. Okay, each ASCII character has 7-bit. Okay, that means it can represent 128 different characters. That's all the letters in the English alphabet, the numbers, the symbols, the commands, everything. Okay. So what they tend to do is an extra bit is added to the start of the binary code. So for example, take 3, the character 3. Okay. So in binary, that's 00110011. Okay. So what you have is, show it you here now. This is the actual code for it, and they add the extra bit just to make it an 8-bit and make it a byte, basically. Okay, it makes it easier for it. Okay, it fits neatly into 1 byte, so it makes it easier. Tagging it on the end doesn't do any harm to it, doesn't do any damage to it. Okay, now you can see that there's a problem there. 128 characters is not a lot, you know. So what they did devise eventually was an extended ASCII. Okay, so you get a full 8 bits. Full 8 bits. Full 8 bits. And that gives you up to 256 possible characters. Okay, so the first 128 are the same, but you get now more extra ones. So that added in things like ifada, those fancy weird little things in different European languages. Okay, but you can see the problem here. It's only European languages, and obviously, as computers, remember the whole point of ASCII originally was it was used to standardize. It was used to standardize the characters so that when computers in America in one college were talking to another college, the information wouldn't be lost or it wouldn't be misinterpreted. Okay, so I'll say it again. I think I got it right this time. The American Standard Code for Information Exchange. I think that, now I don't think you'll ever be asked what that stands for, but the American Standard Code for Information Exchange. It makes sense when you actually read it, why it does that thing. Okay, so you can see the problem with it. Now it still exists. We still use it all the time because very few of us will use more than those set of codes. But obviously, it's been kind of overtaken because of its limitations by Unicode. Okay, and Unicode comes in several different forms and tries to cover every possible character that might be written. In its most common form, it uses 16-bit and 32-bit binary codes. Okay, now first of all, the minute you get up to 16 bits, you're up to big numbers, aren't we? We had a look at 32 bits and something like 4 billion different possible combinations. The best thing about Unicode is that it covers all the languages, even those that use a completely different alphabet. For example, Chinese, Greek, Russian, Middle Eastern scripts. Okay, so you can see why there's that certain difference between the two of them. Now, it is important to know that there are two different character set types out there. There's more than this. Remember, Unicode will also include all the emojis and all the other kind of weird little things you can do. Okay, so if somebody wants to create a new one, they upload their code and all that, and they throw it into the Unicode crowd, and they accredit it and they assign it a new binary digity thing, and then it gets sent out to all the different coders and all the different developers, and they incorporate the new code into their library of possible things that need to appear when you click a particular button. So it is pretty cool, and it is pretty nifty, but it is one of those things that most people would look over it and think, well, why? And again, we'll see this in the next couple of videos. This is why the hex has to come into it as well. Okay, right. So listen, thank you very much. Goodbye.